For lesson 62, we're going to be working with the geometric solid, the cylinder, and that's the only solid we'll be looking at. Now, if you look in your book at lesson 62 on page 412, you're going to see several examples of a cylinder, but as we all know, a cylinder is in the shape of a pop can or a silo. We have a circular base on both top and bottom, and the curvature edge is connecting between the two. We still have our radius of a cylinder. We still have the altitude or the height, okay? And it's these two components that are basically going to set us up for the formulas that we're going to use to find all of these different things. The first thing that we're going to find for a cylinder is the lateral surface area of a cylinder. So for your notes, lateral surface area. Understand when we find this, we are not concerned about the base. What I tell my 8th graders is that when we do the lateral surface area, we're painting the sides of a garage. We're not concerned about the base or the concrete. We're not going to paint the roof. The only thing that we're going to be painting is the sides. So when you hear lateral surface area, just know we are excluding the bases. Here's our formula. Lateral surface area of a cylinder, we always represent it with a capital L. Or I like to use LSA just to be a little bit more specific so we're all on the same page. Lateral surface area is equal to 2 pi r h. Now let's break it down. 2 is a constant, so we're always going to use that value. Pi is a constant, we're always going to use that value. R, as you would guess, is going to be the radius of the cylinder, or the radius of the base. And then, as always, h is going to be our height. So if you look on your page at 413, I'm actually not going to do the example, but I will let you look at it. Okay. For example, number 1, they want you to find the lateral area of the cylinder in terms of pi. They give us a radius of 4. They give us a height of 9. And notice all we do is plug in 4 for the r, 9 for the height, then we simplify and we get 72 pi feet squared. So it's really that simple. As always, it's a formula. You identify what the values are for the variables, and you plug those values into the variables. This is our formula for lateral surface area of a cylinder. The second formula that we're going to talk about is the surface area of a cylinder. Now we are concerned about the area of the base. Okay, we're going to not only paint the sides of the pop can, but we're also going to paint the top and the bottom. This is the difference between what we were just working with the lateral surface area. For the surface area of the cylinder, you can find this formula on page 413, but it goes as follows. Surface area, okay, I like to use SA. The book only uses S, and that's perfectly fine. So the surface area can be found by taking 2 times big B plus capital L. Now let's break these two down. Okay, capital B, what does that stand for? Well, we talked about it the other day, that big B stands for area of the base. Okay, so area of the base. Now what is the shape of our base? Well, if we're looking at a cylinder and we identify the top and bottom of it, it's going to be a circle. Okay, so here we're going to be using pi r squared. That's a formula we already know. Okay, so we're going to find the area of that circle, and then we're going to take it times 2 because understand we got both the top and the bottom. Now, what does L stand for? Well, L stands for the lateral surface area. So we're going to use the previous formula that we just used, and that's what we're going to use for the sides of our cone or cylinder, so to speak. Recall the lateral surface area was 2 pi r h. So that's what we're going to use there. Now, if you look in your book on page 413, they have the 2b plus L as the first formula, but then right below it, they got 2 pi r squared plus 2 pi rh. And basically what they're doing is they're plugging in what we just have in our quotations right here. Okay, that's the formula for each one of those two variables. So as always, once again, to find the surface area of the cylinder, it is 2 times big B, which is always the area of the base, plus whatever the lateral surface area is. And the lateral surface area, again, can be found by taking 2 pi r h. Make sure you get this in your notes. The last formula that we need to talk about is when we want to find the volume of a cylinder. The volume of a cylinder, capital V is what we always use for volume, is pi r squared h. Now let's break this formula down. Notice pi r squared. What does that represent? Well, that always represented the area of the base. So again, we're going to find the area of the circle, okay, whether it's the top or the bottom, and then we're going to multiply it by whatever the height is. So it's a relatively easy formula. We know how to find the area of the circle, and we're all really good at finding the height of a cylinder. So all we do is find the area of the base, multiply it by the height, and we have it. If you need to look at an example of this, you can look on page 414, example number 3, where they are finding the volume of that cylinder. So for lesson 62, we talked about finding the lateral surface area of a cylinder. We talked about finding the surface area of the cylinder. And lastly, we talked about finding the volume of a cylinder, our 3 main formulas that we're going to be using. Now that you have those formulas, I want you to go to page 414. I want you to work on problems A through D from the lesson practice. I want you to try those on your own. If you need help, get with a partner. And once you have an answer for each one of those, then check with the teacher's edition book up on the front desk. Appreciate your work, guys. We will see you soon.